Okay, so hello guys, welcome to the day one of the bootcamp. I will just quickly check if everything is fine. Okay, okay, so it's fine. So I will wait for a few more minutes so that more students can join and we can continue. While waiting, I will tell you a story like how everything started. Since this is just a day one of the bootcamp, so I will tell you a brief introduction on how actually this website communication and communication through web started, because earlier there were many things to communicate, but how does this actually started, I will tell you. So there was a scientist called Tim Berners-Lee. He was working as a nuclear researcher in a facility called CERN is a nuclear research facility. Okay, he was working, and this is an international type of organization where many of the scientists from all across the globe work. So they faced a problem, like if they have to communicate with each other, how can they communicate? Since come or like for example, communication with phone is fine, but like what if they have to share some documents? Like one scientist from Europe research something and have to share the documents to one scientist in Australia. How will he actually communicate? How will he share the document? So a scientist called Tim Berners-Lee, he thought, let's use internet and let's develop a way so that we can share resources. It was started just like this, to share resources. uh, like in today's era, you can see internet has evolved too much. Like you can post something, you can fetch something on the Facebook or Instagram or whatever. But it was started like just to share documents. So on his computer, it was called a Next computer. Next. Next is just a fancy name for a type of computer which was allowed in the CERN laboratories. Okay. On his Next is not like Next computer. Next is just like a type of computer. Okay, it's just a technology, or you can say it's a name. On his Next computer in his laboratory, he developed a web server on his own computer only, and he actually proposed a document, and there was much more going on. But when this was all completed, he was not only like in the development of the first website. You can see this is the screenshot of the first web page running. Okay, this is still live. You can go check out this link if you want to see how actually the first web page looked. So he developed the first web page on his computer. It was using a Next technology, and the browser was Internet Explorer. Earlier was it before Internet Explorer, its name was just www. So he developed a website. Okay, and if you are interested, you can go here. Read more. You can say like a short history of web. I would definitely recommend you to go check out this site. Contains the information, some of the information, and you can see how it actually works. I have posted this screenshot. Okay, so I guess I will start with the actual session. Okay. Hmm. As I have told you, when Tim thought of developing internet, he developing a not internet, developing this way of communication through websites and web pages, or this HTTP protocol. He thought that like this is person A. Okay, this is a person A. This is a document. Okay, let's document, but this is not in his reach. Like they are on a global distance apart. Okay, global distance apart. He has one way of fetching that document is by through mail, but it will take a lot of time. So this person is actually Tim. He developed internet, and the first method, like what should the what sorry, not internet, develop the website. Like what is the purpose of this? So he thought the very first purpose he thought was to fetch this document. He thought I have to read this document. So he want to fetch this document. That's why he created the web. There must be a way to define how to fetch a document, and this is the using get method. Like there are two types of things in HTTP. Basically, the communication is between what? A client. Okay, this is a client. This can either be your computer. Okay, either be your computer. I'm sorry, forgive my writing, or your mobile phone. Yes, mobile phone. For earlier times, it was just a computer. Like this is a client and this is a server. They are global distance apart. This is a server. Okay. So how does this communication look in a way? So actually, when the client have to fetch something from the server, he sends a get request. Get means like, hey server, please get me this document. Okay. The very first line in the request, this is the very first line in the request, and the very first word means what type of HTTP method it is. The very first basic method used was get. Get is using to fetch some document. Okay. Open this up. Okay, let's move it in. It's used fetch. It is used to fetch document, or you can say any resource. So, so this was the very first method. And earlier, when the web was developing, the very first experimental web that came out was called HTTP 0.9. The 0.9 is the version number. It was experimental, and HTTP 0.9 only supports the get method. What do I mean by only support get method is that there will be a server, a central server, and all the clients can only fetch documents from it. This is what I mean by it only supports get method. Like you can't post anything to the server. But as things become a little bit complicated, like for example, there was hmm, things became a little more complicated. Like here is, for example, a person A. Here is a person B. Hmm. This is a central server located somewhere on the globe, and this server actually has some name. Okay, let's leave that for the later part of the session. Okay. So these are two persons. Let's say there is a document in the server, a classified document, a document D. Person one has to fetch this document. What he will do? He will send a get request to the he will send a get request to the server. And how will it look? Like get the name of the document D. Okay. He will send this request and the server will respond with a response. This is called a request. I think you have a little bit knowledge of the basics, like how the communication works. It actually work like in packets. This is a request packet. No, this is a request packet. The server will respond with a response packet. What will this response packet contain? For this analogy, I will say the response packet will only contain a document D. Person A will get this, he will read this, he thinks, wow, it's amazing. He recommends person B. Hey, person B, go to this server. There is an amazing document on something. Go to this server and please wait a minute. I guess my voice was a little bit low. Let me fix. Let me fix my voice real quick, please. Just a minute. I guess it's fine now. Okay. Okay. So we will continue. So person A said to person B, hey person B, go to this server. There's an amazing document. Okay. Go to this server and read this document. So person B will also send a get request. Get D. Okay. The person will specify his address and let's leave that for the later part. Okay. The server will also respond with a response with the document D. Okay. Person B goes through this document and found there is a bit of a mistake in the document and he wants to correct it. So he said to person A, like, hey, there's a problem with the document. There is a issue in this line. I want to correct it. So he said, okay, what's the issue? He said this and that. Then person A said, okay, I think there must be a way to change this document on the server. Because what if someone person C fetches that document, he will see the incorrect version. So So they said, okay, there must be a method, there must be another method so that we can also post our things to the server. And so later they introduced a post method. And when the post method came into play, these all methods were also set up. And this was all from HTTP 1.1. Oh, sorry, 1.0. Don't panic on these numbers. I will explain at the end of the session what does HTTP 1.1, 1.9. This is used to post post a resource, post your document or anything. Okay. Hmm. Come to the this slide. Now they thought, okay, they posted this person B posted a document D bar. On the page. Here comes the story. Person B. Okay. Person B posted his document. The request will look like this. Okay, the request will look like post document D star, for example, because this is his document and the corrected version of the document that he want to post it. And now the server has D bar. Have you noticed something? Like you must have noticed something. Bit of a there's a bit of a lack in this method. Earlier there was document D, right? Earlier there was document D, but now it's D star. So the thing is, when you use post method on a specific location, the existing document will get replaced. So what does this? Post replaced the existing document. Existing document. Post replaced the existing document. What if the C, another person who was trying to access this document, he gets the replaced version D, and he said, wait a minute, where is the actual version? Okay, let's say he might have to make some another correction, but he don't want to copy the whole document. Then he will use another method called put. What does put actually do? It updates the document, not replaces. This method also posts the document, but instead of replacing the whole resource, it updates the resource. Can you think of an analogy in real world? I hope so. Let's say you go to Facebook. Okay, you go to Facebook. You want to fetch some celebrity's photo. So what request will be used? I hope everyone should be able to answer this. The get request will be used to fetch a photo. What if you want to post a comment to the photo, like very nice sir? So the request, the HTTP method will be used is post. Since you want to post a comment, what if you want to update your comment? Not actually post a new comment, just update your comment. Then the put HTTP method will be used. Okay. So now comes delete. Delete is very simple. You can figure out with the using the name only. Delete is used to delete a document. Delete the resource. It's type of harsh type of delete. It actually deletes the document. I mean, whatever you specify, it will delete it. Okay. Patch is just like uh, put in post, like just like a put is used as an alternative to post, so that a new document don't get generated, and just to update. Patch is also used to as an alternative to delete. Okay. Now comes the trace request. You will not see this HTTP method. You will not see this HTTP method in your real life because this is used for diagnostic purpose. But I will need a separate slide so that you can understand it better, because this is a, you can say, a very important HTTP method, trace. And why it's important, you will understand in a bit. Used for diagnostic purpose. Okay. So forget about all the HTTP methods that I just told you, like the get, the post, the put, the delete. Forget about it all. There are more, but these are the basic fundamental ones. So since this is a cybersecurity bootcamp, okay, so on the later part of the sessions, we will be solving labs, and in one of the lab, you will see like a trace is the fundamental thing that you have to use to crack that problem. The trace HTTP method. So understanding this trace method is very important. I will start. Please pay attention to it. Let's say this is your client. Okay, I will use the. Let's say this is a mobile. Okay, this is a client, and this is a Facebook server. This is a Facebook server. Facebook.com. You both are in Asia only. Okay, this is in Asia. Let's say, for example, this is also in Asia. Actually, big companies like Facebook, Google, they deploy their servers in all across the continents like Asia, Europe, China, all. And this is the main server of Asia, Facebook.com. For example, you want to fetch a document from Facebook.com. No, let's not say document. You want to fetch your profile. You went to Facebook.com and you want to fetch your profile. Don't you think that the distance between this can be, I can say, 1,000 kilometers, right? Because Asia is a big continent. Okay. So distance between this and this might be very large. And what will happen if you will, I have to draw this long arrow, we will understand it why. What happened if you want to get your profile? How will it look? Get my profile. Okay, you requested your Facebook profile. Now the problem with this setup is that the client and the server, they are much more distant apart. So don't you think that a packet, HTTP or the data packet, have to travel that long distance just to fetch your profile? Okay, the server will also reply. This will take a lot of time. So they thought the response Okay. Problem. What was the problem in this setup? I mean, everything was going fine. You can get your profile. The server will respond with your profile. Let's say what your name is. Anything that your name is Peter. Okay. Peter.html. Since this is HTML, this will not be a mobile. Okay. It will be a okay. Let's leave it for a later. What was the problem? The problem was with the distance. Distance. Basically, the distance between the client and the server, which led to low latency. Which led to low latency, and you have to wait much more just to get your profile. Okay. So they thought, why not deploy a server and like why not deploy a server near your location. Okay, why not deploy a server in every country? Why not deploy a server in every city? They thought. But you know what is the problem with this? This is too costly. This is not cost effective. So they came up with a very brilliant idea. They thought, okay, let's deploy a server, but we will not pay for it. Okay, these they have to pay for it, but actually they don't own this type of. Some big companies might own this server, but actually these are called CDNs. CDN. What does a CDN is? This is a content delivery network. Since Facebook is a big company, so they might own their own CDN network, but small companies, what will they do? They also have to deploy a server. Let's say they don't have that much money to own their own CDN network. Okay, so these type of CDNs are deployed all over the globe. These type of CDNs are deployed all over the globe, and they are content delivery network. What are they actually? They are just like a server, a middleware server, you can say, a middleware server. And this is the actual server of Facebook.com. There might be a proxy servers between that, but I will not complicate this more. But between a client and a server, there are not only CDNs, there are proxy servers, there are other type of routers. So let's for this to be for the sake of the simplicity, I will assume there are only CDNs, content delivery networks. Okay. So what are CDNs? They are just like a server. They are a middleware server. What do they do actually? Understanding this is very important. Okay. This is a client and this is a server. What do they do? Let's say you requested your web page. Okay. Get my profile.html. You requested this. Hmm. And the Facebook database, okay, the server communicates with a database, but let's leave this part. Okay, the Facebook server has your profile. It has your profile. And the request, your request will go through, for example, let's say will go through the CDN1 and CDN2. Now the packet, I will say this is a packet. This is a request packet. So I will say this is a packet RE. Okay. This is a packet RE. RE means request. This is a packet RE. And this packet contains this line of code. Guys, get my profile.html. This is your packet. And when this goes to this CDN1, now what will CDN1 see? He sees that okay, there's a request to facebook.com made by this client A. Okay, this CDN will see that there is a request. I will not write it like this. What will this CDN see? What will this CDN see? He will see that there is a request to whom? To facebook.com. And by whom? Who is requesting? Request to whom and by whom? By whom? From a client A. Actually, client A has its IP address. That's how everything communicates on internet. But for the sake of simplicity, I will give it a name. By whom? From client A. This CDN will see, and this CDN will receive this packet. Let's say this is a 10 kilometers apart. This and this are 10 kilometers apart. Now the distance is a bit short. Okay, the latency is a bit low. Now the CDN will see that okay, this request has been made to facebook.com and by client A. So he will search for facebook.com and he will see okay, facebook.com server is still miles of distance apart from me. If I send the packet as it is to the Facebook, then what is the meaning of the CDN? Well, like what is the meaning? The distance will still increase. So he will search for another CDN nearby. So this is a CDN 2. He will forward this packet to this. Hmm. Forward this packet to this. And when this CDN 1 will forward this packet to the server, to the CDN 2, the CDN 1 will actually update the contents of the packet, the request packet. And how will it update? We will get in the later part, how actually it updates the contents of the packet. So now the packet is not RE actually, let's say it is RE dash. Okay, this is now RE dash. Now CDN2 will receive this packet. Okay, so what will CDN2 will observe? He will see that, okay, a request was actually this was not a request. Okay, for speaking purpose, I write request, but this is actually the destination of the packet, and this is the source of the packet. The destination, remember one line, okay, throughout the 5-day bootcamp, that the or all your life, the destination of the packet never changes. What changes is the source. What he will do is this will the CDN2 will observe that okay, there's a request has been made to the destination facebook.com and by whom. This time the CDN1 will see that the request was made by CDN1, not client A. Okay, now so hence this packet has been modified by whom? By CDN1. Now for everything CDN1 is fine, he will just forward the packet in the packet, and he will also update, because whenever packet travels from hop to hop, from CDNs to CDNs, it updates a little bit. Actually the source IP address changes, the and the host name. Okay, so the contents of the packet RE dash now changes and it is has now become RE double dash. The Facebook server will see okay, there's a request has been made to a myprofile.html by whom? By CDN2. He will send a myprofile.html to CDN2 as a response. CDN2 no, I will draw the response on another page. Okay, this is just a request page. How does this return journey will look? This is very important because you might be thinking like, what is the need for CDN? Like, for what is the need for CDNs? Since the packet has to travel from this to this to this to this, ultimately the distance has been increased. No, in your mind you have thought of this, like what purpose do CDNs fulfill? If the packet has to travel all the way to the server of Facebook, then what is the need for CDN? So in the return journey, you will understand like why are the CDNs important. For this, I will just draw one CDN. Okay, I might need space. CDN. This is your client. This is your server of Facebook.com. This is your client A. Okay, this is a server. Now the server will respond with a response. First is the response code like 200. Okay, so okay, leave this. just taking space. Server will respond with your profile. Okay, this is your profile. The server will respond, and when this response packet reaches the CDN1, and the response packet reaches CDN1, listen to me very carefully. This CDN, what is the main purpose of CDN? Is to cache. Okay, cache the static resources. I will explain what is a static resource and what is a dynamic resource when we are on, I guess, day 5, oh no, day 3 of our bootcamp, when I will teach you web cache deception. Then I will tell you what is a static cache, what is a dynamic cache, because there are two types of caches. This For this session, let's say this is a static resource. This is a static resource. Okay, your profile.html. Now this is a static resource. CDN1 will do, what will it do? It will cache. Okay, I have written that. It will cache the response. And what do I mean by caching? It will act as a server on behalf of facebook.com. It will actually store your profile. This is your profile. It will store it in his memory and this is called a cache. Okay. And since this is the first response, it will be delivered to you and you are happy. Oh wow, I have received my web page. But the same question arises. What is the purpose of CDN when the request has to travel from this all the way to this, and from the response has to travel from the server all the way to the client? What is the purpose of the CDN? The purpose of the CDN is the caching. This is very important. Now, the next time, for example, you closed your browser and let's say uh, a day after tomorrow, or let's say tomorrow, you opened your Facebook profile again, okay, to see who have liked my photo or anything like this. Okay, you went to get my profile.html. What do you think will happen? Now, does this request have to travel all the way back to the server, or it will have to just travel to this CDN, which is, let's say, just a 10-kilometer apart. Actually, they are not 10 kilometers apart, but for the sake of simplicity, I will say that this is 10-kilometer apart. Now, the main magic arises in this situation when you make a second request. And remember one thing, this is very important. For this scenario, my profile.html is actually a static resource. Okay. Because CDNs are only allowed to store a static resource. Static resource are those resources which do not change with person to person or with information to information. They are same throughout, and entirety. Okay. So this is, I think, good, because now the packet has to just travel from the client to the CDN, and the CDN actually has the response to the, because it stored your cache. Okay, so the CDN has your response, so it will just see. Now the CDN will respond to your client. The CDN will respond with your profile. Okay, now this is of no use. Your The latency has been decreased. What are the advantages? The main advantage is the latency. The late I have to write in clean handwriting. Please forgive my handwriting. Okay. The latency will now decrease. It will decrease exponentially actually. Okay. The latency will decrease. So this is the main advantage of CDN. But everything is fine. Okay. I was teaching you trace. What does trace actually do? Why is trace HTTP method used? Okay. So let's say now I will add a page, because understanding trace is very important. That's why I'm giving trace a little bit of time. Trace and why. Hmm. If you have paid attention, I have told you that whenever a packet, any packet, request packet or response packet travel from one CDN to other, the CDNs actually modify the contents of the packet. It actually modify the request, okay, the request headers and the response headers. So there is a problem. And what is the problem actually? Let's see. There is a problem. For example, this is now you are a, let's say you are a developer of Facebook, okay, but you are not actually at the main center. You are somewhere apart, like miles and miles apart. So now for this you are a, listen to this, okay, then I will write or call it the, for this now you are a developer of facebook.com. You wanted to fetch a resource, let's say my profile. The request goes through this, goes through and goes to this, and the response came, okay. The next time you request your profile, the request goes to the CDN and it came. But at a point you saw that the requested resource, okay, has a little bit of problem. You thought that, okay, there might be some issues. For example, you requested your profile, okay, my profile, you requested a profile. You are observing that earlier your profile came all fine, but now your profile picture is not arriving. So why is that? You tried refreshing the page again and again and again, but the profile picture is not appearing because so you thought like I have developed the backend of the code in such a way that someone when requests his profile, all the details along with his profile photo will be fetched. So why this profile, my profile photo is not, not I'm seeing, why it's not getting returned? So you thought of two problems. Okay. First is the, maybe the server backend code is somehow corrupted, or it's not working as intended it to be. So you contacted Facebook's the main server at Facebook. You reviewed the code. You observe that everything is fine with the code. What is the real issue? Why is my profile photo not appearing? And the second thing which will come to your mind is that, okay, my packet might get, when the packet was traveling from here to here, I have told you now this CDN will update the request and the response packet. So you thought that, okay, maybe my packet was updated by the CDN in such a way that the contents of the packet uh, that was received by the server was not how it meant to be received. Okay. For example, okay, this will be a bit more confusing. Let's say, for example, when the server was expecting a request, it was expecting three things. One, two, three. The first thing it was expecting was that you request for your profile photo, profile pic. Okay. The second thing is your name. Like the second thing it was requesting was your name. The third thing was your details. What do I mean by that is that when the server will receive a packet and will open this packet, it is expecting to see three things in the packet. It was like, okay, the person has to request for his profile photo. Then I will process this code in the backend and will return his profile photo in a request. It has to, request for his name. It has to request for his details. But when the server receives your packet, it does not see your profile photo request. So you thought, okay, CDN CDN might have modified my request in such a way that it removed my profile photo from, it removed the profile photo keyword from my request. Or maybe it could be anything. The CDN could do anything. You cannot directly contact the CDN or you cannot see that. So developers thought like, You must have also thought, like, for example, if this problem arises in your scenario, what will you do? The very first thing that will come to your mind, that is, why not contact the CDN? CDN means the content delivery network. Why not contact the server and see how it's modifying the request? Okay, this is the very first thing that must have to come to your mind. Okay, but there is still a problem in that. There is not only one CDN. If you think that you can, there are more than hundreds or thousands of CDN in between. So it's not possible you will contact all the 100 CDNs and see, okay, this CDN is not modifying my request in such a way that server will not accept it. This CDN is not, this CDN is not. Okay, let's say you got lucky and you found, okay, 900 CDN is modifying. So you can see that this is not a very efficient way to debug. This is not a very efficient way to uh, debug the issue. The second thing which may come to your mind is that there might have to be a way that when I am sending a request, let's say it's a packet, when I am sending a request, I'm specifying some things. Okay. Let's say I'm specifying my profile photo as intended. I'm specifying my name as intended by the server. I'm specifying my details. It might got corrupt, but what if there is a way so that what packet I am sending, I will receive it as uh, I will receive the packet which the server actually received. Okay, let me. I know you guys will get confused in this. I will take a very very simple drawing. Okay, let's say this is your request REQ request. This is your client. Okay. This is a CDN1, CDN2, CDN3, and this is your, not your server, but this is a server. Okay, and this is your packet. I will use this server. Okay, so you thought that, okay, when the request will reach CDN1, the request will modify to REQ dash. Okay, fine, no problem. When the request will go to CDN2, it will go to REQ double dash. Okay, fine. When the request will go to CDN3, it will be modified like this, REQ triple dash, and all the modifications are fine. Okay, it was meant to be happen, but in somewhere in between, like for example, say this modification was corrupted. It was not done by like how it meant to be, like how the server will actually wants the request to get delivered to it. And finally, the server will receive request triple dash. Okay, so you thought, okay, what if there is a way so that I can, instead of getting any response, I can get my request back? But which request? The request that the server receives. This REQ. Okay. So you thought, what if there is a way to actually see what request the server receives? Because you can't always call a server and pull up your laptop and see what request is receiving at this time and this time. You can't do that. So if there is a way to do it, you will see that REQ triple dash is modifying the final modified request does not contain the requested profile image. It does not contain. So you thought, okay, then the problem is with the CDNs. Now what you can do, you can individually send a request to CDNs, a trace request. But so this is okay, I have mentioned, right, so trace why. So that is why earlier slides, that is why trace is introduced in the first place for debugging purpose. Okay, for debugging purpose trace is used. Now for debugging or diagnostics, all this, when I will launch port, okay, when you are actually doing a pen test on a real website on a black box in a black box scenario, sometimes you are not allowed to use trace. Since trace is used for diagnostic purpose, some servers don't allow to receive a trace request. Hmm. But some servers do, and a trace is a very, you know, it's a very important HTTP method to remember, because you will not see this type of HTTP method very often. So it's easy that you will forget it. So I will hope that you do remember this, because on the day 3 of this session, in one of the labs, I will ask from you guys, like, what do you think is the solution? And you have to tell me that, okay, sir, what if instead of using post, what if we change the request type to trace? Let's see what the server is actually receiving in the request. Okay. I'm expecting some positive responses. Okay, what is the next? Okay, request and response. But before that, I will just see if anyone have any doubts. Okay, I will quickly share the attendance link with you guys. Acha, attendance link has been shared. Okay, attendance link has been shared. I will just quickly see if there are any doubts. Hmm. Why can we not use trace? Okay, use CDN server. No, no, trace is not used on CDN server. Trace is a HTTP method. Trace is a HTTP method. You can use it anywhere. If there is a request packet, okay, whichever the what are servers are just a machine, client is also a machine, okay, any machine which generates a request packet, in that machine you can use, instead of get, you can use trace. It might be your computer, laptop, CDN, or anything. Okay, if the CDN is making a request and somehow you hack into the CDN, okay, which is very funny thing, but let's say somehow you hack into the CDN, you can also make a trace request. You can use this request anywhere. CDN means content delivery network. Yeah, CDN means content delivery network. That's a very good doubt. The CDN is all near places. Not all, because communications on internet travel, the speed is of light speed, electricity speed. So it's not like that I'm sitting in, like, let's say on a place A and the CDN is like nearby or like in my neighborhood. It's not like that. But yeah, CDN are there between a client and a server. And the main purpose of CDN is to cache the response. Mark my words, not to cache the request. The request has no meaning to cache. Only the response has the meaning to cache. Okay. So CDNs, can we extract data from web cache? Okay, this is a funny doubt. CDN is a network of interconnected edge servers and a point of view. You are right. Many AI creations. You are right. Yeah, many creations, you are, I think, smart. This is actually the real definition. Trace performs a message loopback. The main keyword is the loopback, message loopback test. Okay. Are there any recent doubts? CDN stores the data requested. No, no, no. CDN does never will not store the data requested. It stores the response received. Okay, and it only stores the static response, not dynamic response. I will get to the what is static and what is dynamic response on the day 3. Okay, I think there is no more recent doubts. Okay, so I will continue now the session. Hmm. So I was talking all about the request and the response and the packet. How does actually a request and a response packet look? This is how actually a request and a response packet look. It might be, you know, different in some. If you are communicating, let's say with a very complicated server. Let's say for a bank server, the response received will, the response received will have more of these fields. Okay. These are called, header fields. The response might receive it. And this is not hard coded anywhere. This is actually, I will tell you later, but it might look different if you are intercepting a request between some other servers. It might look different, but the key concepts are this, because every request and response should have these HTTP headers. Let's get to it. Okay, so little bit. The first line, and the first word. What is this? I have told you, right? This is the HTTP method. And what can you conclude by this HTTP method? This means a client is requesting something. And what does it requesting actually? It requesting this document. Okay, this is the requested resource. Okay. This is the requested resource, this home.html. What is this? This is the HTTP version. On the last page of this presentation, I have the list of HTTP versions, but this is HTTP version. And the current version is 1.1. What does 1.1 mean? You will get to know in the end of the session. The second line, the host. What does the host header field specify? The host header means the browser. Like what browser made this request? This is the developer.mozilla.org. Means this is a what? A Firefox browser. Right. This gives, okay, I will not write this like this Firefox browser. This gives information about the host. Sometimes it can be a browser, sometimes it can be a machine. It depends upon what operating system you are using actually. This is the host making the request. The not intention, this is the making the request. Okay, this is the host. Host. Okay, the user agent. Oh, sorry. Yeah. This is actually the browser, the user agent. Along with the browser, it's very important to share the what do you say, the version number, or you can say the version number of the browser. From this, it's you can say it's a Firefox 5.2, Macintosh, Intel. This information about the user agent. Okay, this is important a bit because from browsers to browsers, the response might vary. Okay, like Google Chrome shows the response in a different manner. Firefox shows a response in a different manner. Okay. The very legacy browser, what was it called? Internet Explorer. Okay. Like Microsoft Bing, the browser by Microsoft, it shows the response in a different manner. So how will the server will know to which response I have to send? It knows by because it asks to the client. It asks like, hey client, uh, give me the information about the browser you are using so that I can, beautify the response and send it to you so that you can, understand it better. That's all. Was accept. This is important. Okay. Accept means, uh, let's say you are requesting your a document. Okay, the document about, let's say you are requesting a document about request and response headers from Wikipedia, and somehow the Wikipedia server sends you a photo. Just a photo, not a photo, just a photo. How will you feel about it? You will think that, oh, dude, I have requested some other resource. You are providing me some other resource. What is this? I want a document about what are request and response headers. You are sending me an image. This will not work. So the server at Wikipedia said, hey dude, you didn't told me that what type of encoding, in the, not say encoding, like what type of document you are asking. So you said that on the first line I have written like home.html. Can't you understand it? Home.html, it's a basic HTML document. So yeah, this is a very fair point. Like this is written in the home.html. But sometimes you can see here there are more things written. Text slash HTML or application slash XHTML plus XML or applications XML Q is equals to 0. This is basically a quality factor. Like quality factors like if this is not what I have received, then this give me this. I am fine with all this. Okay, and this is wild card. Okay, so you have the you told the server that I have written the very first line that this is home.html. What more do you need? So the server said, okay, I have provided you with a home.html document. It's just that the home.html document actually can have the the image. So you said, okay, no, okay, bro, leave that HTML thing. Give me the XML document. I will decode that XML document and present it in my to the client, to the my client who is viewing this computer. This is basically communication between a browser, which is acting as a client, and the server, which is acting, okay, the server at Wikipedia, which is acting like a server. Okay. So you said, okay, give me XML, then I will decode it. So the server said, okay, then specify something, na? If you want this, if if not, I have like if I don't have this, then specify at least a field. So you tell, okay, I will specify a field called accept. This is what I am accepting. Other than this, if you send me anything, I am not able to decode it. I am only accepting this. The response will be dropped. I am only accepting this. Now the server think, okay, you want a text slash HTML. Basically, text slash HTML is the same thing. You want HTML document. If not, then you can share me XHTML plus XML. It's basically a type of XML document. Let's say for this simplicity, XML document. Okay, fine. The server sees the fine. The server says, what if I have both? What will I then give you? If I have both, should I send you both? You said no. Refer to this quality factor. Q 0.9. This is the I will write this, and this is the first homework that you will get. It's not very complicated. It's not very simple, but I will write what is this? This is a quality factor. By homework, I mean you have to research a little bit on this. Like, what is the quality factor? What is the use of it? I've explained, I think, what 90% of it, but I want you to do some things because if you are researching on your own, let's say 1 or 2 hours after the session, everything will be revised. Okay. And what I think is the difference between a good uh, cybersecurity, professionalist and not is that a good cybersecurity professionalist knows one thing. Knows actually basically two things. Okay, leave it. He knows how to do research and he knows where to find the information. He knows these two things. So I want you to research what is quality factor. I've given you a hint that what if the server has both documents? What should he send? Okay, and this is a wild card. Wild card. It's also very important. You will see wild cards in in web penetration testing very often. Not in just web penetration testing, even in codings also. Okay, in development you will see wild card. Wild card means uh, if not this, send me anything. Wild card means everything and anything. Okay. So this is your homework. Hmm. I will specify this is your homework. No. In short, question mark. In short, it's written homework. Yeah, this is your homework. Research on the quality factor thing. Okay. Now, you were requesting what? A request and a response header. A document and a request and a response header. You understand English, but the server returned you a web page in Russian language. You said, hey, dude, are you stupid? I understand English. Why are you giving me the response in the Russian language? How am I supposed to read it? Then the server says, hey dude, are you stupid or what? You have to specify it now. Please specify it. You want the response in English. And this is just accept language, like what type of language you are accepting. English US, okay, English. And here again comes the quality factor. Quality factor 0.9. Okay. I will tell you 0.5. 0.5 means either this or this. 0.5 means 50%. Okay. Not zero quality factor 0.5 means 50%. It's not giving any priority to either English US or English. It's just okay. English US is fine or English is fine. Give me anything. I'm comfortable with English. Okay. Now accept encoding. This is a bit interesting. Okay. Uh, you are seeing actually the response is like this. Okay. These are written in words. But do you think the wires carry this like a packet just like this in words? No. The communication made either wired channel or wired or wireless channel or any type of medium on internet is actually what? Just a bits. 0, 1. So all are bits, okay? And then how are bits? This basically this request is encoded. Then these are converted into bits, zeros and one. Then the zeros and ones are transferred. On the server side, this is decoded. On the server side, decoded and the zeros or ones are decoded in a language, for example, hexadecimal or any type of decoding from the converted, not decoded. And the decoded string, which is the hexadecimal, or you can say any type of decoding. For the web purpose, it's either gzip, dplet, or the vr. Yeah. Then the server will decode this, okay, and then words. So the for the previous analogy, let's say you were requesting request and response headers. You have specified everything. The server said, okay, right, you have specified everything. I'm sending you the response. Okay. When the response received your browser, you are seeing just a bunch of gibberish, just a bunch of gibberish text. So you thought, dude, what is this? This is neither English, neither Russian, neither African. What language is this? This is not even the characters. What is this? So you asked one of your friends, like, dude, what is the problem? And he said, okay, the server has responded in some other encoded language the encoded language is not compatible with your browser. Actually, your browser can't decode what the encoding was. So he said, okay, so this was my problem, right? Everything is my problem. So your friend said, yeah, at least write another header called name it as accept encoding, since this is what you are accepting, and this will tell the server what encodings you are accepting, either gzip, okay, dplet or br. Now the server, okay, I think you have, yeah, this in the response you can say content encoding, okay, they specified that this is encoded with gzip. When your browser will see, okay, this is encoded with gzip, it will decode it because it knows how to decode gzip or dplet or br. Okay. In the referrer field, I guess I'm okay with that. I can go. Then there comes the referrer field. Okay, a referrer is what? When you go to a doctor, he doesn't know what is the problem with you, so he refer to you on to some another doctor which has more educational capabilities than him, or he may refer you to some hospital. So in the report, actually, if any one of you read any medical report, okay, this is the medical report. Will understand it better with analogies, or you will forget it. What does the referrer field means? And even if have you noticed that the spelling of the referrer is wrong? It will be. I think I will be happy if you figure it out why the spelling is wrong and why it's wrong till today. Yeah. So the medical report will contain something in the information like this. The first doctor, the very first doctor you went to, okay, with your problem, like you are coughing non-stop. So you went to this doctor, Doctor A. You went to this Doctor A. Huh. The doctor A doesn't know anything about your coughing. He put his brains and heads all into your diagnostics and all, but he couldn't figure it out what is the problem with you. So what he will do? He will refer to you on another doctor, Doctor B. Hmm. On the last line, he will mention, my spelling might be wrong. Don't know what is the actual spelling of refer. He will actually write this like referred by Doctor A. Okay, referred by Doctor A. So when the Doctor B receives your report, he will see, okay, so you came from Doctor A. You didn't directly came from me, you came from Doctor A. So it might be good for Doctor B so that he can understand what is the problem with Doctor A couldn't understand. This is just how a referrer feels. Okay. Host, actually, okay. Host is not that thing that I told you. Okay, sorry, I'm sorry. Host is the website, developer.mozilla.org. It's a website on Google. If any one of you are using Linux, okay, and you open the browser in the very first tab, you will see something like this. This and the combined URL would be like this. Okay, it will be HTTP and update in secure equals 1. So it will be HTTPS dot www dot, and this field will be specified. Okay, host. I'm sorry, I might have zoned out. Okay, and this field will be specified developer.mozilla.org. Okay, the host. Then after the and okay, leave it. Okay, after the host, this field will be specified slash home slash HTML. Now the combined field, the combined URL will be like this. Okay, this is HTTPS. This is the you can say the method. No, not method. This is the protocol. HTTPS is the protocol. Okay, this is the protocol. I will tell you what is the protocol is. Protocol when I will come to this what connection. Okay, this is the protocol. You are using HTTPS, and this is the URL. This combined is the URL. So this is the link. First will be the host www.developer.mozilla.org. Then there will be a home.html. Okay, please forgive me for my mistake. And the user agent actually tells what type of browser you are using or what machine the request came from. Now comes connections. Keep alive. This is a important. Okay. I will keep it short since I have to. Okay, I will do it this tomorrow, and this will be okay. Since tomorrow, okay, I will give you a brief introduction. Okay, since this is a day one, so I will just tell you what is the basic web architecture, how does it work. If I have time, I will show you how burp suite request and responses look like, how to intercept a request. Okay, and the for day two, I have planned to actually teach you in detail the authentication vulnerabilities and access control flaws. So whenever on the next day, like tomorrow, if by chance I'm not left a bit much time, so I will skip this part, authentication sessions and cookies, because I will be teaching you in depth on tomorrow, and we'll give this. Okay, this is for what? No, this is a layer 4 protocol. It would be easier for you to understand if you have any idea about what is a OSI model. What does the OSI model is? If by chance you don't know what is the OSI model, it's not much complicated. I don't have much time, so I will not go in depth with OSI model. But I would, if you don't understand, then please go to the internet and see what is the OSI model. The layer 4 protocol. Okay, this is a there are two layer 4 protocols, TCP and okay. Just a minute, guys. Just a minute. Let me see. Are there any relevant doubts on this? Okay. Hmm. If I have the time, then I will take all your doubts at the end of the session, all your doubts. Okay. Time is running out. So there are there are two layer 4 protocols basically. This is the TCP, this is the UDP. TCP stands for Transmission Control Protocol. I will not write everything. How does the Transmission Control Protocol see? It has a means of communication three-way handshake. I will only tell you the relevant part of the TCP. How does actually the HTTP is a layer 7 protocol. But before you make any connections through HTTP, the client and a server has to go through a TCP three-way handshake. What is a three-way handshake? Let's see what is a three-way handshake. Basically, this is TCP. TCP. This is client. This is server. This is the client line. This is the server line. And between this will happen a communication between the client and a server. Before any before you communicate with the HTTP protocol, before any of the requests and the responses are sent, the very first thing that a client do is to make a three-way handshake with a server using a TCP protocol or HTTP. What is a TCP three-way handshake protocol? The first client will send a SYN packet. Why is SYN packet used for? SYN packet, this is fundamental part of networking, but SYN packet is used for many purpose, like to see if the server is up or not, or many packets. The SYN is the full form of SYN is synchronize. Synchronize, okay. The server, let's say, is up, and for example, you are making a TCP connection to some specific port. Let's say you are making a TCP connection to port let's say 443. 443 is used for HTTPS communications. Okay. Port 80 is used for HTTP communications, and nowadays HTTP is outdated. Nobody use HTTP since it's not encrypted anymore. So let's say the client sends a TCP sync packet to the server at port 443. If the server is up, there must be two things. The server must be up. What does that mean by up? It has to be running. Second thing, firewalls on the server has to be configured in such a way that port 443 is allowed to communicate on the internet. How should I write this? Uh, Ready to connect? Let's say ready to connect. Hmm. There are two things that have to match. First, the server has to be up. The server has to be running. And the second thing is that the server must listen to port 3, like the firewall is allowing outside connections to his port 443 and is allowing uh, you know outgoing connections also from port 43. If these two circumstances are all well, then the server will respond with what? The acknowledgement. ACK packet. No, sorry, not ACK packet. The server will acknowledge it. This is a bit confusing since the server will acknowledge with a SYN packet. SYN means synchronize, ACK means acknowledgement. How does acknowledgement? What does acknowledgement basically mean? The server is telling, hey client, I am up and I am ready to connect. When client will see the acknowledgement, he will conclude, okay, the server is up and he is ready to connect with me. He will send a third packet called the acknowledgement. Acknowledgement packet, short for ACK. So how does the flow look? SYN ACK. Okay, SYN ACK. The client will send the third packet called ACK. Okay. So when the server will receive this third packet, it will eventually know the connection has been made. Now you can communicate all things, all your HTTP, all your request, all your response. You can make it, but there is a problem. There is a problem which arrived with HTTP 0.9. You remember I have told you HTTP 0.9, the version before that, or HTTP 1.0. The I think yeah, the connection. This problem is still with HTTP 1.0. That's why HTTP 1.1 came. What was the problem? HTTP 1.0 doesn't have this header, connection keep alive. Okay. So I will tell you the problem. What is the problem? There is a client. Okay. There's a client. Not my There is a client. There is a server. It made a three-way handshake, three-way TCP handshake, and both clients and servers are now ready to share information. And as a client, for example, as myself, I'm making a TCP three-way handshake to Facebook servers, and after the after the handshake is complete, I requested for a resource. For example, my profile.html, I requested this resource, and the server responds with the response. Okay, like, hey, Mayuresh, this is your response. This is your thing you have asked for. The moment I received that response, traditionally, what used to be the scenario is that there is the moment there is a one the one transaction, you can say that like transaction has been completed, this TCP connection is to be closed. TCP connection is closed. And how TCP connection is closed? Basically by either the server send the reset packet or the client send the reset packet. It's the two-way thing. If the server wants to close this connection, it sends the reset packet to client. The client wants to close the connection, it sends the reset packet to the server. Okay. The main problem is, think with your mind, with your using your minds. The main problem is after the one transaction has been completed, uh, this this TCP three-way this connection TCP connection is closed. Then you might have think, what? Okay, I'm browsing my profile. What if I have to go to my friend's profile? What will then happen? Again, this will happen again. TCP three-way handshake will happen again with HTTP 1.0 or earlier. This TCP three-way handshake will happen again. Huh. And then one transaction is allowed. Only one transaction is allowed, and after that, the connection is closed. So, so what is the issue that arrived? The issue which is arrived the bandwidth. Okay, this whole thing is taking too much of the bandwidth. I mean, think na कि that all if before making any request, you have to first perform three types of request and response. It's the TCP three-way handshake. So it is consuming some bandwidth. The main problem arises the problem of bandwidth, not latency actually. Latency is a different thing. The main problem is the bandwidth. So they thought how to overcome this. They thought why not only make why not make the TCP connection last until one of the client or the server has done communicating. Why not make this connection last for whatever time if they are communicating, the connection will open. And this problem was solved in HTTP 1.1 or later. 2.0, 3.0. This problem is solved by introducing what? Keep alive header. Keep alive header. Keep alive header tells you what? Keep alive header, it tells that keep the connection open until I am finished communicating. This is the keep alive header. It's very important, and it was introduced in HTTP 1.1 and later. HTTP 1.0 doesn't have it. So if there are any connections using HTTP 1.0 or HTTP 0.9, you will rarely see. But if let's say you are browsing any legacy websites and you somehow say HTTP 1.0, you will you will notice that there is a lag. There is a huge amount of bandwidth is consumed. So this is also done. I will be going a bit fast now. Upgrade insecure request. This is used. I will just orally tell you because this is not very important to write. Okay. What is this used for? Let's say you are initially making a request to the server and you are using the HTTP protocol, which is not actually secured. So when the server will receive this request, so before providing any response, okay, before providing any uh, basically upgrade insecure request one means like convert my this HTTP session to HTTPS so that this is it's now encrypted. Basically, this is all it's used for. And if modified since and if none matched are used for caching purposes, when I will get to the and also cache control. This is all three are used for caching purposes. On I guess on session 3, there is a web cache reception. Let me see. Hmm. On the day 3, I will teach you web cache deception, and on that day I will tell you what is a cache, what headers, request and response headers are uh, responsible for caching. But it would be great if you read at least a bit about it. This is what a e tag is. This is a e tag. This is not very complex thing. These are all you can research on ChatGPT or Google or anything on Wikipedia. Or the best way is the MDN docs. Okay, Mozilla Developer Network docs. You can go through that documentation and get at least just about what is a e tag is, what is these three headers. Okay, let's come to the response header. If your requested response is if your requested resource is in the server and it will respond with a 200 OK. 200 is what? It's a status code. Status code. 200 OK is not a status code. Just 200 is the status code. OK, just you can say a more human readable version of it. Let us server saying OK, this is the request. Access control allow origin. When I will teach you CSRF, then I will tell you what does access control allow origin means. But for the definition purpose, I will tell you what I will not write it because it will take time. So, what does access control allow origin means? Uh, for example, when you go to Wikipedia, you are reading some things, and if you have browsed through Wikipedia, you will see that in the Wikipedia there are external links to external resources and external resources to any of the servers. It you may get external resource to Facebook. Let's say Wikipedia is telling you to go through this Facebook post. So how does it what access control allow origin means? Like the Facebook has to be configured in such a way so that it receives request from all origins. That it can uh, you might be thinking like, oh, this is fine, what is the problem with this? But when it comes to cross-site request for the server-side requests, this is important. There are, if I remember right, there are three options to it. And what is this? I've told you now, this is wildcard. Means the server is responding, the server is saying basically, okay, any origins on the internet is allowed to communicate with me with no restrictions. This this is uh, this is a wild card. Means anything and everything. The server responsive to the connection keep alive. Okay, the server and the client has come up with a basic understanding of, okay, let's not break this relationship before marriage. So the server and the client has come to a, and this is the content encoding. The server is basically telling the, let me, you will not be able to see. Okay, the server is telling the client, okay, the response I'm sending is encoded with the gzip encoding. Okay, and the content type is what? It's what? HTML document, and the character set is UTF-18. UTF-8. Basically, character set is important for emojis and other stuff. And the response is generated. E tag. Okay, this is also for cache purpose. I've told you, and if you paid close attention to it, this e tag and this e tag are same. I want you to research on how, I mean, why they are same and what will happen if they are not same. Okay. Keep alive timeout uh, 997. It means basically the server is telling me, the server is like your what? Your toxic partner. Okay. The server is a toxic partner. The server is telling you, okay, I will just keep this relationship for 5 seconds. Then the client thought, okay, in 5 seconds, I will send you 5,000, 6,000 requests. Then your toxic partner said no for 5 seconds, and only maximum of 997 requests are allowed by you. So basically, the server is, it's for security purpose and for bandwidth also purpose. That it is there is a restriction on how long you can keep the session this TCP connection open, and how many maximum number of requests you can send in a TCP connection. Okay. Last modified still for cache purpose. Okay. Uh, for cache purpose, last modified basically for cache purpose. It says that when was this response was last modified. If this is not, then use the cache response, or if this is modified, I will send you a new response. Okay. You will rarely see this type of response header, because this is telling the client in the information about the server. It is telling that the server is using a Apache. I mean, the server is a machine. Okay. The server is basically a computer. It's a machine. And inside that hardware box of thing, there is a software called, either it can be Apache or Nginx. Like Apache is used in Linux distributions. Nginx is used in I think Mac and Windows. Okay. So what is a server? Server is a software running on a hardware. Okay. So this is Apache. As a cybersecurity students, you must pay close attention to the information like this. If you will go to more advanced hacking purpose, then you might right now you think that this information is irrelevant. Will I do knowing that, okay, the server has running an Apache server? What is this do? But this gives you two things about, I mean, you can conclude two things about the server using just this header. The first thing is this the server is running on a Linux distribution. Okay. It might be a VMware, but basically it's a Linux distribution. That's why it's Apache. You can verify it if someone here from the networking background, so you can verify it also by ping. You can ping your server, and the TTL which come, like time to live. Basically there are different TTLs for different type of distributions. I have Windows with 128, and I think Linux has 68, but 62 I think. I don't remember right now. But this is what you can actually verify it. Like what type of operating system is server running. If this is Linux, it might be hard to penetrate. Okay, because Linux are open distributions. It can be updated in any way. And second thing, the response might come with the version number of Apache, let's say Apache 2.0. Then go to Google, search for Apache 2.0 and search for its latest vulnerabilities. What are the latest vulnerabilities with Apache 2.0? And see, okay, these are the vulnerabilities with Apache 2.0, and you can exploit the server basically. Don't do this. I'm not actually, encouraging you to exploit the server. This is just for security reasons. Okay. This is like what different type of things you can conclude from just a simple information like a server response header. Set cookies. Okay. For the next session. Okay. It's, I think 1.5 hour. So for the next session, set cookies used for authentication purpose. Okay. Transfer encoding chunk. Not very relevant to the course, but I will tell you. Basically, there are two types of encoding that the server may do. First one is bitwise encoding. The second one is chunk. Bitwise encoding means it will include bit by bit, and the chunk encoding means it will pull out a chunk from the response, encode it, then send this chunk. Okay. Nowadays, everyone is using chunk encoding because it's faster and it's easy to decode and all this stuff. Okay. Very. Okay, very. I will come to it later. Just a minute ago. Okay? Just a minute from now, because vary is used for CDNs. Okay. X backend server, X cache info, X schema revision, X frame options. These three are, let's say, these three are not relevant. Okay. This is a bit relevant. Read it as your homework. X X cache info. Skip this. Okay. Skip this schema region. It's not at all relevant. Backend server, what servers are running and what is. Read this if you have time. X frame options. This is X frame options. Yes, sir. Okay. I will come to the vary part, then I will come to the X frame part. Okay. What does vary mean? Where is my CDNs? This is the CDN. I will not write it, otherwise it will get very messy and hard for you to understand it later, huh? So vary. Let's say a server responded. Uh, I will take an example. It will be easier for you to understand. Okay. What was vary? Uh, for the explanation purpose, I will use vary except encoding. Okay. Except encoding as vary. What is this? You might forget it later, but it's okay. It's not that relevant. Okay. Huh? What does vary mean? Where is my diagram? Let me use a new diagram. Hmm. Vary. This session might get a bit long. But since this is the day one, I am trying to give you all the, all of the things so that for the later sessions it will be easy for you to understand. So it's good if you are attending, you know, if you are here with me. So very, this is a CDN. And this is a server. Let's say this is Wikipedia. What is the spelling of Wikipedia? I think this is this Wikipedia. And this is a client. There are two clients A, client B. Okay. What was it? It was accept encoding. No, let me change it in a way so that you can understand better. I will change it like, not this. Vary, instead of accept encoding, I will say accept language. It will be easy. No, okay, let it be accept encoding. It's more relevant. CDNs, vary, accept encoding. Okay. This is client A, this is client B. Its browser is configured in such a way that it only decodes BR, and the other was what? Jizu. His browser supports only, sorry, gzip. Gzip. Okay. His browser only supports gzip for encoding and decoding purposes, and this browser only supports BR for decoding purposes. Okay. And there is a CDN in between both of them. Both will communicate with the CDN. So let's say browser A requests a document on India. What is India? What is the history of India? Everything from Wikipedia. Huh? So the CDN will send a request to the Wikipedia requesting India. Wikipedia and this for this request packet, the client A will mention that okay, accept for his request field, the accept encoding header will be what set to what? Tell me. The accept encoding header will be set to BR for this client. Okay, since this client only supports BR, like if I am supporting, like I can only understand English, then I will tell the server that okay, respond with English, not with Russian. I am not able to understand Russian languages. So accept encoding BR, this is one of the request headers which was contained by the request which was made by the client A. This request travel all the way to the server. The server send a response with the response field like encoding BR. And this is this since this is a static document, this is not anything dynamic or contain any personal information. So CDN will cache it, and CDN will not cache the text version of it. CDN will cache the encoded version of it. So encoded versions take less bandwidth to travel. Okay, and they also take less space to load, to store also. So what is this? What was telling? The CDN server will cache the first copy. I mean the let's say the copy which was for A, and it has what? BR encoding. It will encode it, and this will provide it to the this BR encoding will be provided to server A as response. Okay. Now somehow server B also wants to uh, get some knowledge about India. He's not from India. Okay, he's not from India. He's using completely different browser, completely different uh, computer, completely different operating system. So he also wants some information about India. He also requested that information about India. But in his request field, it says accept encoding. Okay, accept encoding gzip. Since it's not able to understand anything apart from gzip, so he will mention accept encoding gzip. But the dilemma is that his request will send to the CDN, and the CDN will see, okay, the request was made to slash India, and the CDN will see, okay, I have a cached copy of India. So why will I forward this request to the server? It will take too much time. Why not just I provide this response? The CDN will respond this response with slash India, but with what? With encoding BR, because he cached the response which has a BR encoding, like it's encoding with BR. Okay. So the problem is, so the client B was not able to decode anything from it. He's not able to understand anything from it. So there comes this vary part, vary accept encoding. It tells the server, basically tells it's for basically CDNs, or okay. It tells the CDN that okay, store different copies of the request as cache according to the this field, to the value of this field. Means if a response came which has accept encoding as BR, okay, it doesn't specifically uh, mean that it has to be the request, this has to be response that this India, no. But if the response has accept encoding field, take the accept encoding field as an account. Okay, if this is BR, cache it. If another response came as accept encoding BR, then don't cache it, because we already have the cached version of the encoded response with BR. If let's say by chance if another server sends another version of the response which has different accept encoding, for example, if it has different accept encoding like gzip, then you should definitely cache it. Okay, this is very important. Okay, revise it. I will tell you, revise it, or otherwise you will for you know it will just vanish from your heads. So revise it. It is not that relevant, but still it's very important, because when you will go deep into the web penetration testing, these type of HTTP request and response headers are, plays a major role. Okay. Then CDN, what will happen? The CDN will store a different copy for cache B with encoding gzip. Now, very header field can take like more than one type of things. Okay, it is cookie. What does cookie means then? Cookie means then store different versions of responses based on different versions of cookies. If a cookie is, let's say, 1, store it in your cache. If the cookie is 2, also store it. It doesn't mean if the response is from Wikipedia from the same resource, it doesn't mean. If the cookie is different, then store it. And just like this, if the accept encoding, this field, it's the accept encoding is different, store it. It doesn't mean if this is like this, the requested resource was slash home dot html. It doesn't work like that. Just store it. Whatever things are written in vary, store it. Okay. If this is cookie, then if the response has different cookies, store it. If the response has different accept encoding field, then also store it. It means this is for different users. So finally, I will just say that go through the slide again. Things that I've told that these are homeworks, please go through it. It will be helpful for you only. What is left? I will take this tomorrow. Write it tomorrow. Oh, sorry, this is not the spelling for tomorrow. Okay, tomorrow I'll take this. Basically, I was planning just to give a basic how does authentication mean. I was planning to tell you a story about how authentication started or and everything. Okay. And what is the most basic type of authentication? But I guess the time is constrained here. Time is a constraint here. So I will tell you everything about authentication sessions and cookies tomorrow. And tomorrow also is your first lab. Okay. Tomorrow will be your first lab. One more thing. One more thing I will tell you. Setting up the environment guide, as I have told you in the start of the session, because somehow I knew it that the session might take long and I will not be able to show you how to set up everything. But you are not, little childrens. You are here in the session because you know much more things. Okay, and you are interested in learning cybersecurity. So what I want to do, I mean, what I want you to do is go to the internet, do two things. Actually, you can set up Kali Linux on either on a hypervisor or from dual booting or a separate laptop you can use. But the most efficient, I will say, for learning purpose is use a hypervisor. Hypervisor. Type to hypervisor. Okay. And for this, I will recommend to use VMware. VMware workstation. If you don't know what is a VMware workstation, go to Google, search it. What is a VMware workstation? Basically, it's a type 2 hypervisor. What is a hypervisor? Go to Google, search it. If you have any doubts, ask me tomorrow. In the start, like today, I have started a session without taking any doubts because I knew there will be no doubts in the beginning of the session. But from tomorrow onwards, I will start the session at 7. I will wait for it, I think, for 10 minutes. And 10 minutes, I will take all your doubts. So if you have any doubt which is left to answer in this session, please ask me tomorrow on the next session. I mean, in the start. Okay, please join early in the start. Ask me. And yeah, this is go to Google, download VMware Workstation. You can use Pro. Pro is free now to use. Okay, I am also using VMware Workstation Pro. You can also use VMware Workstation Pro. Go to the website VMware and something. Yeah, or you can YouTube it how to install VMware Workstation Pro or how to install Kali on a virtual machine. Then the second thing, use Kali Linux. VMware, or it's up to you. I want you to experiment. You have 24 hours of time till our next session. So you have plenty of time. I want you to experiment. You can use either a image.iso image, because in VMware you can burn .iso image also. Okay. Or you can use a file, like there is a separate file, Kali VMware file, just a folder which has files. You have to load one file and everything will be pre-installed. Okay. Any if you will do these two things correctly in your Kali, burp suite comes pre-installed. Don't panic if this is the community version. I will be using community purpose for the demonstration purpose. Okay. Some of the labs require pro version of the burp suite because pro versions uh, supports out of band connection with the server. Okay. So for that, you can just watch, or if you have a pro version, you can download it, or you have any other way to get the pro version, you can also do that. Hmm. So basically 90% of the session, I would say 95% of the all the session, the 5-day sessions and the practical labs will be covered in the community version. Open the burp suite. Do three things. Sorry, just do one thing for me. Setup. This is important. Setup burp suite. What do I mean by setup burp suite? If it's come pre-installed, what does it mean by setup burp suite? Setup burp suite so that it intercepts a request. Basically, when you open Burp Suite, you will see a tab called Intercept, and I want you to set up your Burp Suite and also install the CS certificates and all, and set up the Burp Suite. While you are setting the Burp Suite, okay, at a point of time, you will be doing something like this. You will go to your browser. Hmm. You will go to your browser. Then you will go to Network tab. Okay. We will go to Advanced. Everything will be guided in Google or anything you are, I mean, on any resource you are referring to set up your Kali and Websuit. Okay. But this is the normal thing. You will face this. Okay. You will go to Advanced. Then in Advanced, you will see four options. The last option will be what was the last one? Proxy. Websuit is what? Websuit is a proxy server. It's a software. Proxy server, proxy software. We'll say proxy. And in proxy, there are two things that you have to enter. The first you will enter in the proxy is the IP address, and in the IP address you will enter 127.0.0.1, or you can also enter localhost. And in the port section you will enter 8080. It will differ user to user. If you are not a beginner like me, if you are more advanced, you can run your proxy server on some other computer, and then you will the other computer on the same network, then you will enter that computer's IP address in this field. And if you have configured burp suite to run in on any other port rather than 8080, you will enter uh, other port information. But basically these two will be common in all the beginners just like me. Okay. What I want to do is I want you to look up why 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 you are entering this and this, like why you are entering the IP address of the local host. What is the local host IP address? What basically is local host? What is 127.0.0.1? Why is this so special? What is this so special about it? And the second thing, what is a port? What is a port? The second thing, what is a port? Why you are using 8080? What are IP and port? Okay, I want you to research on these two things. I will ask tomorrow in the beginning that what you guys have researched on the homework that I gave you guys. Okay, and I will give a shout out to those who will answer correctly why we are using 127.0.0.1 and why we are using port 8080. Basically, why? What's so special about 127.0.0.1? And the person with the you guys who come up with the best explanation, the best and the easiest explanation, but get a shout out from me. Okay, read this introduction to OWASP Juice Shop. You will get your homework, or not homework, your project. Okay, or like on the if you have come here, you must have read the documentation. On the fifth day, you will get a project, and I'm planning to give you a project on this topic, introduction to or not introduction to Juice Shop. I will give you you know uh, perform a pen test on OWASP Juice Shop. Based on the vulnerabilities I will teach you, or if you have anything else in mind, it's very great to read and do a pen test, write a report and submit it. So this is for the day 5. Don't panic and don't take much stress about all of the project and why 127. It's just for interest purpose. If you have interest, you can do it. If you have not the interest, then it's okay. Okay. No worries. You know I will make your interest in this. Let the day 2 and day 3 come. But read this, and not only read this, go to Google and search for what is OWASP Juice Shop. Install it in your VMware. If you have time and if you are, much more curious mind, install OWASP Juice Shop in the Kali Linux, or not Kali Linux. You can use you can use the entire distribution of OWASP Juice Shop on, on a VMware. You can use install it OWASP Juice Shop. It will be very convenient for you guys as well. Okay, now comes the last point and the end of the session. So this was the experimental thing. experimental thing. Okay. I will summarize this in 10 minutes. The HTTP 0.9, it only supports get method, means you can only fetch documents from the server. When HTTP 1.0 came, it comes with different headers and status code. Different headers means the starting of the session I have told you different headers like get, post, put, delete. There are a lot of different headers. Okay, not a lot in the lot of sense. Like apart from the headers I have told you, there are codes, and it also introduces the status code. Status code are basically from, like, there are 100 series, like, 100, 200, 300, 400. These are basically series codes. 500. Read it through it. Like 200 means okay, 201 means something else. 500 means internal server error or the website has moved. Okay, these are basically server code. Status code. Status code basically tells the client, okay, so this is the basically server sends a code to the. We'll get in later part, and this is not that very difficult. You have must have heard anywhere in your life about the status codes. 100, 200 is okay, this is very common. 500 internal server error, basically there may be error at the server and website moved permanently. If there is a status code, what is, I don't know, let's say the status code is X for, you don't have to remember all this. Okay, if there is a status code X for website move, you must have thought why this is important. So just example, let's say you received a server code, like a stress code, a website moved permanently, that the address of the website is now changed, then the response will contain the new address of the website. Okay, this will contain the new address of the website, the web page, new address of web page. This is what? This is the status code. HTTP 1.1, as I told you, it introduced with a very important HTTP header, keep alive. It is used to keep the session open, keep the TCP connection open for a while, like until I've told you, so I will not repeat it. It's getting, you will get bored. HTTP 2.0 supports multiplexing. What is this? This is not relevant, but this is an interesting thing. Uh, let's say this is HTTP 1.1. Yes. I have time, right? Yeah, I have 8 minutes. I will just 8 minutes. Okay. HTTP 1.1. This is HTTP 1.1. Let's assume the TCP connection has been made. Okay. TCP connection has been made. Okay. Now this is client. This is server. Okay. Just a quick. This I will be quick. Okay. The problem is you have solved one problem. Keep the connection open. But the problem is there is a defined flow of the packets. When a client requests a packet, request one, only then the server is allowed to respond. The first thing, oh sorry, the first limitation, it will be solved in APIs. What? I think APIs, no? No, not API. It will be solved in WebSocket. When we will switch to WebSockets rather than HTTP, we will see that this problem has been solved in WebSocket. Now it's not necessary that if the client is request only, then the server is responding. The server can respond at any time. So this will be solved in WebSockets. I think there is I have included topic WebSockets in the session. I guess second, third, fourth, or fifth. I don't actually remember, but there is a topic for WebSockets, and it's very interesting. Okay, that's why I have connected all the sessions. So that's why it's important for you to learn why we have moved from 1.1 from 1.0 to 1.1 to 2.0, and why we have moved from HTTP to WebSockets. What was the problem with the HTTP that we moved? That not It's not that we moved. We still use HTTP. WebSockets are used on HTTPs, but what was the need for WebSockets? Okay, so there was this problem which was solved on WebSockets. I will write this in the next slide. Let me write. There was this problem one. Problem one. When a request has been made, only then the server is allowed to respond. Okay. And the solution was WebSockets, introduction of WebSockets. The problem two. Let's say if you, I told you earlier that I was fetching my profile and I have sent three requests to the server. The server to return my profile photo, my name and my details. Okay. So I will make three requests. Okay. I will make three requests to the server, and the server will have to respond me with the three responses, three different responses, one containing my profile photo, one containing my name, and one containing the details of me. Okay. The problem is when I will first send the, when I will send my first request, which will be about my profile photo, then I have to wait for the response of the server. I can't just send concurrent requests like I send three requests at a time. I can't do that. Like it will be easier for me, right? Just sending three requests at a time and waiting. Which one arrives first? It will load. It will be easier. But that was not the case with HTTP 1.1. You have to actually, right, it was with HTTP, yeah, HTTP 1.1. You have to actually wait. When the first request goes, and the response has to come, okay, uh, then only the client can make the second request. Okay, this will be the pattern of the request responses. Okay, I mean, okay, this coming out. The request and responses, request to response to. You have to wait. Now, so the problem was what? You cannot send concurrent request. Okay, this is the problem. The solution was multiplexing. Very simple. If you can't send the concurrent request, just send the concurrent request. I mean, develop the client and server, develop this whole scenario in such a way that concurrent request can be, made. So the solution was multiplexing, and it was introduced in HTTP 2.2. Introduced in this and used later. Introduced. In HTTP 2.2, it was introduced. So now, how does it look? HTTP 2.0 multiplexing. Multiplexing. How does it look? Same things. This is the client. Okay. This is a server. Very simple. Now the client can send three or more than three or two concurrent requests at a time. Concurrent requests at a given point of time. Okay. Point of time, and the server will respond in its own lazy manner or fast manner, whatever it thinks is convenient. And the client, whichever the response comes first, will render the response on the browser so that you don't have to wait for the response to come. Might be very good inconvenient, you get lagged in between. So this is the multiplexing. It was introduced in HTTP 2.0. Okay, I will introduce it. HTTP 3.0 is basically a whole different story. It doesn't use TCP connection at all. Basically, I guess in 2012, Google start developing, because at least for the, these from 0.0 to 2.0, are using TCP connection. And after you have seen, right, in the 5 seconds of the limit, after 5 seconds, another TCP connection will be made. So, and the problem with the TCP connection is mainly with three-way handshake. Three-way handshake is very reliable. Okay, it's reliable, but it is slow as compared to UDP. Read about TCP and UDP if you can't understand this, but I have not much time, so not be able to explain this. But think the TCP is making three-way handshake, it will be slower, right? And UDP does not do any handshakes at all, so it's faster. But UDP is not reliable. If any packets in between are deleted or might lost, so there is no way of recovering that packet. While in TCP, if some packet is lost in the way from receiving from the server to the client, if some packet is lost, the client will request that packet again from the server. This is the beauty of TCP. So Google thought, okay, let's combine this fast mechanism of UDP can and the reliability. We will develop something reliable. Okay, so Google start developing, I think in 2012 or something. It start developing quick, and it was introduced in HTTP 3.0. This is not at all relevant. Okay, but just a head start that HTTP 3.0 is now in scenario. So it's quick over UDP. It doesn't use TCP connection at all. It uses UDP connection. Okay. So now I think everything is done. Okay. So thank you so much, guys. You guys are great. Let me see how much of you are actually with me right now. I'm sure a lot of you have left. Let's see. I'm sorry, the session is a bit, you know, delayed, so might not be able to clear your doubts. But yeah, 73 people. Shout out to 73 people. The session was a bit long. Okay. If anyone is, extraordinary student and is interested, his interest level is the peak of the interest, then go read this document. This document is long as hell. Okay, long as hell, but it is very informative. Very, very informative. If you read this document, there is no way you will ever get any doubts like how this happened in web penetration testing. Right. Okay, guys. So I guess I will end this session now. You guys are great. The 73 people are great. Okay. So, okay. Do your homework and go rest and sleep. Okay. Bye, guys.